My name is Danko Emmanuel Kendo, and I welcome you to Kentech 96 TV. So I've been going through dimensional analysis. Let's solve this past question, and this is Wassce 2023. And in the question, the frequency f of a wave in a string is given in terms of length L of the string and tension T. Remember, tension is a force in the string, and linear density rho by the formula F equal to 1 over 2L root T over rho, whereby this L is representing length, this is tension, which is a force, and this is rho, which is linear density. We are supposed to obtain the basic units of F, which is frequency, using dimensional analysis. So this is the question given: F equal to 1 over 2L root T over rho. So now we have to find the dimension of each of the parameters in the question. So here we need to find the dimension of L, which is length. And dimension of length is L. This is tension, which is a force, dimension of tension. And remember, force is equal to mass times acceleration, and the dimension of mass is m. Acceleration is LT minus 2. Then, dimension of linear density, which is linear density is given as mass over distance. So the dimension of mass is m, and distance is L. So minus 1. So let's substitute this dimension into the formula. So F is equal to 1 over L is 2L root. So instead of the tension, replace it with its dimension, m T minus 2, all over the linear density, m L minus 1. So here m will cancel m. So we are going to have F equal to 1 over 2L root L T minus 2 over L minus 1. So there's L here, and any number is raised to the power 1. So here I can have F equal to 1 over 2L root L squared, or L raised to the power 2, T raised to the power minus 2. So I need to find a way to remove the root. So here, remember, root is the same as half. So you can bring the bracket and put half it. So I can have F is equal to 1 over 2L L squared T minus 2 all half. So here, this will cancel this, and it will cancel this. So I'm going to have F equal to 1 over 2 pi 1 over not pi 2L L T minus 1. So here this L will cancel this L. We are going to have F, which is equal to 1 over 2 T. Remember, in the question we're supposed to take the value of this 2 is just a figure which is dimensionally constant. So here this F can be written as 1 over T, which means F is equal to 1, F is equal to T raised to the power 1. And here this T is time, and time is measured in seconds. So we can have frequency to be equal to S raised to the power -1, which is 1 over S. So we are going to have f equal to 1/2 t raised to the power -1. Remember, the 1/2 is just a figure and is dimensionally constant, so I can have f to be equal to t raised to the power -1. So here, obtain the basic unit of f. So here, this t is time, and time is measured in seconds. So my f will be equal to s raised to the power 1. So this becomes the basic unit of f. Question number 2. The mutual force F between two bodies depends on the product of their masses. So we are having two bodies, and each of them is having a mass, let's say m1, m2, and the magnitude of m1 is equal to the magnitude of m2. The distance of separation d and the universal gravitational constant G. Use the method of dimensions to obtain the formula for F in terms of m, d, and G. So let's solve this question. So here, the mutual force, which is F, depends on, so the depending variables are the product of their masses. So I'm going to have m raised to the power 2, distance of separation d, and the gravitational constant G. Remember, this can further be written as F is directly proportional to J m squared d. Then the next step to do is that the dependent variables, remember this is the dependent variables and this is the subject. So per the steps, the dependent variables are raised to a certain powers. You can either use A, B, C, but here I'm going to use X, Y, Z. So F depends on J, X, M, 2, Y, then D, Z. D raised to the power Z. Then what I need to do is to remove the proportionality sign and replace it with an equal to sign. So F is equal to K, J, X, M squared, Y, D raised to the power Z. So this is what I have here. F is equal to K, J, X, M squared, Y, dz. Then you find the dimension of each of the variables in question. So here you need to find the dimension for F, and F is force. So the dimension of force. Remember, force is equal to mass times acceleration. Mass is m, acceleration is Lt minus 2. Dimension for mass is capital M. Dimension for distance, which is length, is capital L. Then dimension for gravitational constant is equal to m raised to the power minus 1, L raised to the power 3, T raised to the power minus 2. So let's substitute whatever is here into this equation. So we are going to have, instead of force, we are going to have m Lt minus 2 equal to K to bracket m raised to the power minus 1, L raised to the power 3, T raised to the power 2, multiplying x, m squared multiplying y, then L multiplying L raised to the power z. So here the m squared is raised to the power y. So what is left for us to do is to calculate the values of x, y, and z. And remember, this can further be written as m raised to the power 1, L raised to the power 1, T raised to the power minus 2. So by comparing the left hand side of the equation to the right hand side of the equation, you'll be able to calculate the values of x, y, and z. But let's further simplify this. So here we are going to have k m raised to the power minus x, because this is multiplying the whole bracket. L raised to the power 3x, t raised to the power minus 2x, n raised to the power 2y, l raised to the power z. So we have L here, M here, M here. So we can simplify. So when we simplify, we're going to have m raised to the power 1, L raised to the power 1, T raised to the power 2 equal to k m raised to the power minus x plus 2y, because this is indices. If the bases are the same, you add the exponent. Then the next variable is L, which is 3x plus 2y. Then finally, this is 3x plus z. Then finally, you have t raised to the power minus 2x. So now let's find the values of x, y, z by comparing the left hand side of the equation to the right side of the equation. So let's take m. So we are going to have m raised to the power 1 equal to m raised to the power. Okay, let me start with the t first to make it very simple. T. So we are going to have t raised to the power minus 2 equal to t raised to the power minus 2x. So here we are going to have minus 2 equal to minus 2x, and x will be equal to 1. Then we can move on to the L. Here, L raised to the power 1 is equal to L raised to the power 3x plus z. So we are going to have 1 equal to 3x. Remember, x is 1 plus z, and L will be equal to minus z will be equal to minus 2. Then finally, you can solve for y. And to solve for y, we are going to have 1 m raised to the power 1 equal to m raised to the power negative x plus 2y. So here we are going to have 1 equal to minus x. Remember, x is 1. So minus 1 plus 2y. If you simplify this, y will be equal to 1. So let's move to this side of the equation and substitute the values of x, y, and z here. So I want all of them to occupy the board. I don't want to kill anything. So here I'll have my f, which is equal to k j, x is equal to 1, m squared, y is also equal to 1, then z is also equal to minus 2. So I'm going to have something like f is equal to k j m squared over d squared. Remember, this k, the question says we should assume the value of the constant to be 1. We are going to have f is equal to j m squared over d squared. And this is the equation or the formula relating f to m, d, and g. Thank you for watching Kentech 96 TV, and do not forget to share the video to your friends. Thank you.